All right, hopefully we can get through this one a little bit better. All right, so here we are, we're in the 1900s, and this is where things really start to get interesting. Technology has progressed quite a bit. The observation tools are much better than they used to be. And we start to get electricity widely available to all. And that will really start to change the way that these people can do experimentations. All right, so here we go. Max Planck, or Max Planck, I guess is technically the way to say it. In 1900, he introduced the idea of quanta to explain the color of light emitted by certain heated objects. All right, what Max Planck saw is that when you heat things, sometimes they give off different colors, like the same thing that's being heated. At one temperature, it might glow red. You've seen this just if you look at a campfire. You can see some dark reds, some light reds. Maybe if you even got it hot enough, you would see some whites. If you look in the flame as it comes out, it's yellow and sometimes blue. So it was all from one process, the actual heating of wood, but you get many different colors. So Max Planck wondered about this, and he came up with this idea of quanta. What it means is that energy, that's the blank, is not given off continuously, but in small packets called quanta. Okay, so what he said is that these different colors of light are emitted because as the thing is heated, it gives out different amounts of energy that are specific amounts of energies, and those energies relate to certain wavelengths or colors of light. Now, that's kind of a hard little thing to think about, but we can grasp it. Quanta, it's like stairs, and I'm just making this up as I go along. But you have the option to go up one stair, and that's just a little bit of a lift of your foot, or you can go up two stairs, and that's kind of a larger, or you can jump up to the third, or if you're really feeling the gusto and risking hitting your head on your roof if you're me, you can go for the big full-on four-step. All right, you have those four options, and they require different amounts of energies to get up. Now, if I was to fall or jump, it would be the same process. I would have four levels that I could jump from, but I would not ever be able to jump up 3.5 stairs. There is no half stair. I'm either at the third or the fourth. It is a very distinct level. Energy, or as Max Planck is going to call it, quanta, is that same way. It means quantized. That energy is only emitted at specific wavelengths, and those wavelengths relate to specific colors. So if these were my stairs, we would have just, here's our floor. It didn't take much energy to get up there, so it's not going to take, or I'm not going to get much out by coming back down. All right? So this amount of energy would relate to a small amount of energy, or a low wavelength, or a low wavelength color, like red. But if I was all the way up at these top of these stairs, this is what my boys do all the time. They pile pillows at the bottom of the stairs and see how far they can jump. Pretty soon I'm going to take them to the hospital with a broken arm, because I think they're up to 6. Is that right, Bill? They are up to 6 stairs now, which is 2 stairs taller than either one of them, at least, right? All right, I'm getting an amen from my wife. All right, so it took a lot of energy. If I was going to jump all the way up there, I could get a lot of energy back out. And that big fall would give off a big wavelength, or sorry, it's actually ironic, but it's a very short wavelength or high energy color, and that'd be something like blue. All right, so the key to this little section is quanta. It's quantized amounts of energy. They are very specific, and there is nothing in the middle. They are one or they are nothing.